What does pencil show?
Serpent cat. Serpent cat holds all answers. All right. So, we're not going to do this whole page together because there's a whole bunch of these, and about half of them wind up showing up in one of the homeworks that we have coming up, I think, next week. Oh my gosh, what? So we're going to practice through some of this, kind of identifying this and seeing what the heck we're even looking for here. There are a few different ways to go about this. So we're going to talk it through a whole bunch of times. So what is your instinct for this first one, for A? Are those the same? Are they equivalent? No. Why? I'm not saying you're wrong, but why?
The one in the parentheses on the left is subtracted, and the one in the parentheses on the right is added.
Yeah, you're not wrong. That is in fact true. But is that going to change the value?
It can.
When in doubt, test it out. Pick some things to substitute in. When we're doing these and we're saying, are they equivalent or not, you can always test these with substitution. However, small caveat. Never, ever, ever test with 0, 1, or 2. You can use 5. 5's fine. Just never use 0, 1, or 2 because 1 times anything is whatever that thing was. And it's really hard to tell if we got it right because 2 times 2 is 4, 2 plus 2 is 4, or 2 squared is 4. They have too many things in common. And 0 just has a tendency to throw everything in a wrench. So pick 2 numbers. Pick a number for A, pick a number for B. Test it out. Just don't use 0, 1, or 2. Put up here, if testing, it's not your only strategy you can use, but if testing, do not use 0, 1, or 2. I'm just writing it down so we have it in case we look at stuff later, okay? What do we see? Are they the same? All right. So what did you use for your A and B?
I use
Used 4
I
for
used 8.
4 for both. So we had,
8
and you used 8 for which one?
for the second one.
8 for B,
Yeah.
and you used 4 for the first one. What did you use for A?
So 8.
Oh, you used 8 for both.
Yeah.
Did anybody pick some mismatches? 5 and 6. We did 6 and 3. 7 and 9. Did they match for all of these? Do yours. Try yours. Take your same numbers into this piece as you do over here. So you're going to take like your 5 and 6. 5 plus 3 minus 6. 5 plus 3 minus 6.
Are we allowed to use negative numbers?
You can. We're just testing to see if the expressions are equivalent. These are just the numbers people were using.
Yeah.
Okay.
The only rule is you can't use 0, 1, or 2.
No, you do
We're
it.
just seeing if the expressions are equivalent.
So, okay.
And we
Yeah,
just,
for me it's the same too.
it's the same. So it worked for some of these, and some of these, and some of these, and some of these, right? So are the expressions equivalent? Do they mean the same thing? If you got the same answers both times for all of these values. Yes. When we are doing adding and subtracting, like this, are parentheses, that's what's called commutative or associative. Associative is about what is grouped. Commutative is about where it is. So yes, these are expressions. These are equivalent expressions. They mean the same thing. It doesn't matter if I do this subtraction first or the addition first. They do the same thing.
Question.
What's up?
Couldn't you also, because it's 0 equals 0, if you put them equal to each other, wouldn't that also tell you?
That would be another way to test it. We just aren't doing that because we're working with expressions instead of equations.
Well,
Yeah, but it would do the same thing. Yes, you could do that.
Because that's what I did.
Right.
Use that
Instead of just plugging it in.
calculator.
Yeah, you can put them in the calculator. When you're doing your substitutions, put them in the calculator. That's fine. Let's look at the next one. Are these equivalent?
Yeah.
We still can't use their one.
Still, never ever. When we're substituting into tests, never ever ever use 0, 1, or 2. Just pull those out of the use them to test things bank in your brain. Never ever ever.
Wait, why not? Because it won't be the same.
0 times anything is 0, so it kind of messes everything up.
Right.
1 times anything is whatever the heck it is. So I can't tell if it's keeping or changing things. And 2 times 2, 2 plus 2, and 2 squared all have the same thing. So it's hard to tell if it's the multiplying or the addition or the squaring that's making something happen weird. Okay? So never, ever, ever, if we're just testing them, should we use those? So I know our instinct on this one was yes. Test and see. Test and see. Pick a K value.
10.
She heard you.
I definitely did. Even though you sounded kind of like a duck when you did it.
No, my bad. I was joking. I was like,
Oh.
That did not sound like joking. I got middle schooler at home. My ears are very attuned to words we should not be saying
No,
in
they're
school.
not the same. I got 4 for the first one. I used the value of 10, and I got 20 for the second.
Yeah.
Like the second one give a whole number.
Yes. Excellent observation. Excellent observation. So you can absolutely go through and test. We used 10, and we got 10 divided by 5 being 2, plus 2 is 4. 10 plus 10 is 20. So substituting in, we got different values. We can also look at this and go, well, wait a second. If I choose anything that's not a factor of 5, that sucker's going to be a fraction, which means decimals. And the right one, that's not giving me decimals. There's nothing wrong with decimals, but all we're looking at is, are these two things the same thing?
right.
We can have decimals. Decimals are fine,
No, it's not.
especially when we're using calculators.
That's okay.
So these are not equivalent.
I haven't plugged them into each other. U get K equals 10.
That is the...
That is a U get.
No, that shouldn't be where they're equal.
No, they're not. Okay.
Oh, okay. Yeah, no, they'll be parallel.
U get K equals 10 if you do it.
All right, so those are not equivalent. We're going to practice this a couple more times just so we can see it, because we sometimes get our brains stuck on these and they are going to show up again. We'll see these over and over. So I just want us to practice it a couple of times. Okay? Because it's a little weird. Especially when we start throwing things like powers in. So these are the next two.
No.
And you don't have to do this with testing. You can look at these and kind of read it. You don't have to test values. Test values is a great way to fall back if we're not quite sure what is happening. But you don't have to do these with testing. iPad's talking to my screen again. It was 100% argumentative this morning.
Hmm?
I'm just really glad my iPad and my screen are willing to work together again. They were fighting all morning. All right, what do we think on this first one? Are they equivalent?
No,
Yes, they are. What are you talking about?
I'm gonna say,
No, they're not.
I'm gonna say no because I
They're
said
not.
It'd be a squared plus ab squared.
No.
No.
I was gonna say, go ahead.
When the expression is in a parentheses
Mhm.
and squared, that's the same expression multiplied by itself.
Multiplied by itself. So if you think back, algebra 2 style, we'll get to it again. This is the same thing as a minus b times a minus b, right? Distribute that. The boxing or with our arrows, when we have this guy, these guys. If I was to multiply this out, I'll take those arrows back and I'll do it. So we're going to have our a times a giving us a squared. We have a times minus b and minus b times a, which gives us minus 2ab. Whoever's music on is super loud. I can hear it up here. It's coming from this direction. I'm going to go with the one who's bobbing his head. I can hear it. Music. If it wasn't your music, it was nearby and you were bopping along. So plus b squared. So if I multiply that left piece out, we get this. Is this the same as that? No. When we have powers, we can't distribute them. It's not the same thing. Okay? We love distribution. We love it. But we can't distribute powers. So these are not equivalent. They don't mean the same thing.
so I was right.
They do not mean the same thing. To be fair, most of you guys were right.
Yeah.
Which is great. Because this one is called a perfect square trinomial when we multiply it out, perfect square. This one is a special pattern, algebra 2. Difference of squares. So they're different. They're similar. I'm with you there. They look real similar, but they are not exactly the same. How about the bottom one? I was like, I'm giving everybody a chance to look. What do we think? Bottom one.
Wait, who said yes? Then I'm gonna agree now.
You said you were going to agree or you're going to be contrary?
I'm gonna be different.
You're going to be different. You're going to say no. So defend your no.
There is no way to defend it because she's right.
I love it. Okay, go ahead and play devil's advocate even though it's wrong. I love it. Thinking first, like I love the independent thought. Because you guys are absolutely right. This one is our distribution. These are equivalent.
Yeah.
I just was not expecting that and nearly snorted water when you said it. Okay, that is the same thing as if I distributed it 3 times z, 3 times w, which would be 3z plus 3w. Same deal. Okay, so when we get to, I want to say it's homework 3, which would be the one I put up for next week because spitting things out. It'll have more from this page. It'll also have a couple other things, I think, but unless it's been ages since I wrote it. So I just wanted to go through that because we get a little stuck. We stare at it and say, what the heck are you even asking? Just are they the same or are they not the same? And how do we know? So what we're going to do today, what we're going to spend the majority of our time on is going to be pages 20 and 21. 20 has this picture on it and 21 should be all covered in dots. The dot page. There we go. while we're looking at this, I'm actually going to take it back here for a second because I want to ask you guys a question. When we multiply like this, do you guys draw it like this? Or do you like to do the box method?
What is that?
Box, where we take our A minus B times our A minus B. That way? Okay, I was gonna say, there were several schools that do it this way and several schools that do it this way. They do the same thing, but we're gonna take a look at what the box method is showing us today. So we'll see it. So those of you that don't know box method, we're gonna see that today. This is 100% the exact same thing. Okay. So I just want to just do a real quick check-in to make sure that everyone wasn't going, no. Because I know a lot of schools are starting to dial back from the box method. All right. So we're going to start here. We're looking at this picture where we've got lengths of 1 and lengths of x, all marked on this line segment. And what we're going to do first is we're going to find pieces that are these sizes. So I'm looking for a piece that is x plus 1 long. Where would I find a piece that is x plus 1 long?
The one where it says 1 and
The one where it says 1, and then there's an x right next to it. So this is x. This is x plus 1. So all together, this purple piece is x plus 1. Right? It's a segment. Segment addition. This is pulling a little bit of geometry back into it. X plus 1. That's our segment addition. What if I needed 3x plus 1? Oh my gosh, guys, stop. What are we talking about?
You go first.
To the first x to the third x.
Yeah. So I need to have 3 x's. So I'm going to come here and go, all right, I see an x here. I see an x here. And I see an x here. And then I need a 1 as well. 3x plus 1. So each of these pieces individually, I've got 1, 2, 3 x's and a 1. So all together, segment addition-wise, I have 3x plus 1. If I take a segment and I add it to another segment, it adds together. That's really what we're trying to see. How about if I needed 3 x plus 1s?
You use all 3 1s and all 3 x's.
All 3 1s and all 3 x's. I have, so for 3x plus 1, I'm going to use this kind of, that looks yellow, but it's supposed to be green. I've got my x plus 1 that we did first with our purple. I've got another x plus 1 here. Boop. And I've got another x plus 1 here. So that gives me 3 x plus 1s, right? 1, 2, 3. What these are doing is these are looking at if we were to build the box, when we do the side and we split it and we would do our 3x plus 1, it's making the side of the box. That's what the side of the box is for. We're taking that plus and splitting it there. So then what we're going to do is we're going to look at the dot page and we're going to do some drawing rectangles. Not full art stuff. And we're going to do some things. We are going to be drawing 4 rectangles on here, so don't make your first choice of rectangle be a giant one. Okay? Draw a rectangle that has all the dots on the corners. So just draw any rectangle on your page that has all 4 corners on dots. Like, boop, boop. Like that. I hit dots with all my corners. I'm not great at drawing straight lines, but I hit dots on the corners. It doesn't have to be in the corner. Just that, like, this guy needs to be on a dot. This guy needs to be on a dot. this guy on a dot, and this guy on a dot.
Oh, a rectangle.
Yeah, yeah, yeah. And then on your rectangle, I want you to find the length and width of your rectangle. What is your length? What is your width? Mine is 4 by 11. Yours is probably different. And my next question is going to be, what is the area of your rectangle? How do we find the area of a rectangle? Length times width. I was not asking Siri. She's trying to be very helpful, and she tried to give me the formula. My love, I know that. So we can find our area by taking our length times our width. So for me, I'm going to take my 4 times my 11 to get 44. What's up?
Yours is 5 of them. Instead of 4.
Oh, I count the spaces. So like 1, 2, 3, 4.
Or supposed to count the spaces.
You can do however you count it. That's fine. Me.
Just for me.
Hang on, I gotta do the natural thing. I don't know people's names off the top of my head yet.
Is it for me?
Working on it.
What?
Like, no, this is not for you.
This space.
This is right. Okay, just double checking. Working on it. I'm awful with names. All right, so what we want to notice here is that I could do this 4 times 11. Excellent. But I could go, oh shoot, I forget my 11s when I'm multiplying. I forget how to do them and I don't have a calculator with me. But I could break this into pieces. I know that 11 is made up of 1, 2, 3, 4. 5 plus 6. That still makes 11. And I could do this as 4 times 5 plus 6. That is an absolutely valid way to do this. I could do it as 4 times 10 plus 1. So I can do this as a multiplication by parts, is what this really is. It's an area model that does multiplication in parts. So it's really helpful when we have a number and no calculator, especially if we have something like 13, and we're not necessarily quick with our 13 facts. We could do a 10 and 3. We're pretty good with 10s. We're usually pretty good with 3s. But we might not know our 13s off the top of the head. So then what we're going to do on our next one, because we're going to draw another rectangle, I need at least one corner to not hit a dot. At least one. Can be more than one, but I want at least one to go in between. A rectangle, yes. So we're gonna draw a rectangle that has at least one corner that's not on a dot. So we can't fully count our width or height. Boop. At least one that's not on a dot. It doesn't matter. You don't have to do 4 height. You can do whatever. I'm just trying to make it not be all the way at the bottom.
Stop.
You okay? There we go. Okay. So what we're going to do then is we're going to do the same thing. We're going to find our area, but we don't quite have all of our dimensions. On mine, I do happen to know my height is still 4. And it went past my 11, so I can really see that this is still my 11. But I can't tell how far that is, and we don't have a decimal to estimate it. So I'm just going to call it x. So for my rectangle, yours is probably different. What is the area of this piece right here?
44.
44. It's the same rectangle that I had above, right? What is the area of this piece here?
We don't know.
We don't know exactly, but what do we have? We have an x on this side. How tall is it? 4. So how could I find the area here?
4 by 4.
It's not necessarily 4. This is in between. 4 times x. So 4 times x. It's not, though. It's in between. That's why we put it in between the dots. It's almost like I have a reason. All right, so I can find my area of my second one by taking either my 4 times the 11 plus x, which is the length of my top, or I can look at the insides and have the 44 plus 4x. That is 11 plus x inside. Sorry, I just wound up really close to the edge, so my words are getting very small. I can make it a little bit bigger. Is that better? I was like, I can make it bigger, but then we're going to lose purple. There. Okay. So it's kind of putting together these pieces on how we find the area. We're going to do 2 more rectangles. And the next one, I need more than 1 rectangle to not be on a dot. And dance to your music and just like absolutely kill it. It turns out so fast when I start dancing. Oh my goodness. I am shocked, right? Oh my gosh. I will do bad dad dances if the music becomes a problem. I've been known to bust out the sprinkler and the shopping cart.
What's the shopping cart?
You don't know the shopping cart?
Oh.
Look what you did.
I mean, to be fair, that is now an Olympic level dance move. It was no joke thrown in the Olympics in the breakdancing competition.
Breakdance.
Uh-huh. Breakdancing was in the Olympics this year. It was a choice. Huh? They don't have American football in there this year. And to be fair, they won't have breakdancing the next time. All right, so we're going to do another rectangle, but this time I'm going to have more points, not on dots. And we might just do one more. This might be our last one, just because I don't want to take up every single second of our time. I know. So I'm going to go in between here. And I'm going to go in between here. There we go. Oh, sorry. I didn't realize I still had this zoomed in all the way. All right. So I just went in between on 2 of the corners, which wound up putting the third one in between. So very similar vibe. And what this is going to become, one is going to look a whole lot more like box multiplication. And where that comes from. Because I don't know the exact length of the top. It's in between dots. I don't know the exact length of the side. It's in between dots. However, I can tell pieces. I can tell that this piece is 4. So I don't know this one. If I don't know it, I'm going to use a letter. We're very comfortable usually with X. And on the top, I don't know its length either. So I can go 2, 3, 4, 5. Let's go here. That's going to give me 8, just because I didn't make it super wide. And that right piece, again, I don't know its length. So I need to use a letter. I've already used X, and I cannot say that for sure those are the same size. So I'm going to use a different letter. What's a letter different than X you want to use?
Fine.
Why? Fine with me. Variables are placeholders. I do not care if you use X or Y or A or Z or Q or happy face, heart, smiley face. I don't care. They are placeholders. You can use whatever you want as a variable. To find our area here, where we're trying to find the length of, and I'm just going to write below, my top side, which is 8 plus y, that is the length of that top segment, right? And the length of this left side, which measures 4 plus x, we can multiply inside. So what would the area of this big piece here be?
Oh,
32.
I was going to say, have confidence in yourself. You said it right, and then you took it back. 32. I was going to say, you had it, and then you just took it back. You were like,
We'll just do my own right here.
Yeah. So mine is 32. So what would be the area of this piece here?
4y.
4y. Because I have 4 times y. What is the area of this long piece down here?
8x.
8x. And what is the volume? Or not volume, area of this piece here is xy.
I didn't know we were doing volume.
And we're not doing volume, we're doing two-dimensional shapes. So I can write my area either as the product of the sides or as taking all those areas and adding them up to get our 32 plus 8x plus 4y plus x, y. And you guys just did polynomial multiplication in 2 variables. That's what that is. That is multiplication with more than 1 variable. You did that. Huh?
Can we just get rid of it? No. I never liked it.
But this is where the box method comes from. This is how that works. You don't have to draw them to scale. More often than not, when we do box method, we just do like a square like this. And we do our 8 plus y and our x plus 4. It doesn't matter. You can flip-flop them. Because you're right, it is 4 plus x, but x plus 4 is the same thing as 4 plus x because I can scooch my addition around and they're still equivalent. Equivalency, yay.
But normally you only have one missing variable.
Normally we'd usually work either with the same variable where it would be x plus 8 and 4 plus x, or however, associativeness. Or we'll only have one missing variable. We're not going to do a ton with 2 variables, but since we were doing this with pictures, we were not going to wind up with the exact same missing space. So there's going to be all kinds of ways we can do this, and we're going to work more with area model just a little bit, but more than that, it's about focusing on distribution and what that does as we get into distributive property next week. But we're going to work with these and equivalent expressions and shapes that represent equivalent expressions in the activity that we're going to start tomorrow. So, boop. If you have not yet done homework 1-2, I recommend you do so. That test date is still wrong because I still haven't gone through and update these. It is the 23rd. The 25th is a Sunday. We're not taking a test on a Sunday. The test will be on the 23rd, which is a Friday. Next Friday, in fact. Next Friday, in fact, a week from tomorrow.
That's game day. That test on the first game was crazy.
I totally 100% knew that it was a game day.
You did? Can we move it to Thursday? Could you move it to like a Thursday or some hump day time? Right, so
No,
we
you
did
want us,
this.
we want to be able to have time to review. Like, we want to be able to go through stuff and work through
No,
stuff.
we just heard we get it up. the
Thursday,
way.
Thursday's like my birthday
We
day.
do it on Thursday?
That's my birthday day.
Oh, yeah, and we're like, we, like, do it on